Okay, pause, copy, try this exercise. Pause, copy, try. So I'll find the vector parametric equation first. So VP, x is equal to x0 plus SU plus TV. X0 is any vector that is on the plane. So you can just use this point in its vector version. For U and V, I need two vectors that are parallel to the plane. So if I call this point A, this one B, this one C, I can say U is equal to the vector AB. I'll draw a picture over here, which I'll erase. Here's my plane. Here's A, here's B. So the vector that connects them, I draw my origin here, it'll be parallel to the plane. So pause and copy that. I'm going to erase it right now. Right now. Oh. U is equal to AB, so I do 0B minus 0A, which is, what do you get? So I'm basically taking this point, subtracting this point, and I get 0, negative 1, 1. Now for V, got to be a bit careful. You can't do BA, because that would be parallel to AB, but you can do AC. That will be acceptable. So I do C minus A, I get minus 1, 0, and something else, 1. So I can write out my thingamabob here, 1, 1, 0 plus S times U plus T times V. Okay. Now, what to do? Find the normal. Find the normal equation. Find a normal equation. This one I'll just give you the answer. I already did an example like this just a moment ago, so I'll just give you the answer, and you can ask me in class if you're having trouble. So what did I get? X plus Y plus Z. X plus Y plus Z is equal to 2. Okay. Intersection between two planes. Pause and copy. So what I'm doing here is trying to find, let me write it down. Intersection is equal to solution set of this system. And by this, I mean the system consisting of these two equations. 1, 1, 2, 3 is my first row. 1, 2, minus 1, 5. I just row reduce this. Familiar operation. And if I didn't make a mistake, then I'll be set. Always good to double check. 5, 1. Okay, so what does this tell me? It tells me that x plus 5z is equal to 1. Y minus 3z is equal to 1. So my x, which is x, y, z, is equal to 1 minus 5z, y, 1 plus 3z. Pulling this apart, we get 1, 0, 1 plus z minus 5, 0, 3. What has gone wrong? I feel like something is funny. Not funny, haha, but just a little bit off here. Let me just have a gander. 1, 1, 2, 3, yes. 1, 2, negative 1, 5. 1, negative 3, 2, yes. Subtract. Oh, I screwed up down here, didn't I? Beep. Sorry about that. Correction incoming. So my mistake was y is equal to 1 plus 3z. You probably picked up on that quicker than I did. Okay, that's more like it. So what does this tell me? The equation I want is the equation of a line. So I can give a description here. Intersection is this line. If you think of two planes intersecting in space, that is a line. I hope you see that. Did I make another mistake? Oh, I did make another mistake. There is a 1 that should be a 2 here. 2. 2. 2. 2. Okay, now that looks okay. Anyways, two planes intersect in a line, or they don't intersect at all. Here's a little picture you can ponder for the case where you have three planes. How about you just look here? You can see what I was just talking about. Two planes, the intersection is a line. Okay, these look like squares, but you're meant to assume that all of these squares extend to infinity in all directions. You can see there's this line of intersection between the red and the blue. So you can actually see, oddly enough, if you have three planes, you could have a point of intersection. Okay, the idea is that two of the planes intersect in a line. And then the third plane is intersected. Let me draw that line again. We got this line here, which is the intersection of the green and the red, and then it hits the blue plane in exactly one spot. So that's possible. Or you could have just a single line of intersection, or there's a variety of ways where you can have no intersection. One that's not shown here is if you have three planes that are parallel, and none of them are the same plane. So just to give you an idea, to help you think about the case of three planes, which I believe you'll see in your homework.